Hi dears, today we can see CSAR net and set related max problems. So this is from part B. How many real roots does the polynomial x cube plus 3x minus 2023 have? So options 0, 1, 2 and 3. So such type of questions we can use Descartes rule of sign. So the polynomial fx is equal to x cube plus 3x minus 2023. Here the different signs are plus minus. So we can take that as 1 root. Now we have to replace x as minus x. So that this become minus x cube minus 3x minus 2023. Here you can see no opposite signs are there. So there are 0 roots. So the real roots are here we have 1 positive root and here 0 positive root. So totally 1. Okay. The question is asked as a real root. So there is only one real root. So option B is the right one. If the question is imaginary root, then total which is equal to here you can see 3 roots. 3 minus real root is 1. So 2 imaginary roots. So as per this question, real root, the answer 1 is right. That is option B. Next question, which of the following sets are uncountable? The first, set of all functions from R to 0, 1. Let's take option wise. First one, the function, set of all function R to 0, 1. So set of all functions you have to find means cardinality of B par cardinality of A, which is equal to here cardinality of B. Okay, coordinate which is 2 and here cardinality of R which is C. So 2 par C which is uncountable. So the question is uncountable. So option 1 is the right one. Let's see the second one. Set of all functions R to 0, 1. So set of all function is B power A, cardinality of B power cardinality of A. So here the cardinality is 2 and cardinality of N is aleph naught. So 2 power aleph naught which is equal to C which is uncountable. So the question is uncountable. So option 2 is the right one. Let's see the third one. Set of all finite subsets of N. So we know that n is countable, that is cardinality of n which is equal to aleph naught which is countable. So whose finite subset is also countable. The question is to find as uncountable. So option 3 is the incorrect one. Let's see the fourth one. Set of all subsets of n. This is the fourth option. So set of all subsets means itself power set. So power set of n. So power set of n is equal to 2 power n. Right. So 2 power cardinality of n. So 2 power cardinality n is aleph naught. So which is equal to C. C is uncountable. So the question is uncountable. So option 4 is also the right one. So in this questions 1, 2 and 4 are the right options. Next question, let alpha equal to integral 0 to infinity 1 divided by 1 plus t square into dt. Which of the following are true? First question, d alpha by dt equal to 1 divided by 1 plus t square. Second one, alpha is a rational number, and third and fourth. So let's see the first one. Alpha is an indefinite integral. You can see that in the 0 to infinity. So d by dt of alpha is not equal to this value. Usually we will write that d integral sum x into dx means it's a direct reverse process. Then we will write the remaining. But here you can see that it is an indefinite integral. So such cases is not apply for this one. Okay, d alpha by dt is not equal to the integral value since it is an indefinite integral. So the first option is incorrect. Right. Let's see the second one. Alpha equal to integral 0 to infinity 1 divided by 1 plus t square dt. So which is equal to tan inverse of t from the limit 0 to infinity. So tan inverse of infinity minus tan inverse of 0 which is equal to pi by 2 minus 0. So pi by 2, pi value which is equal to 3, we know that 3.14 etc. Right. So which is not a rational number, it is an irrational number. So we can say that option 2 is incorrect. Let's see the third one. Log alpha. So log alpha is equal to log, here alpha value is pi by 2. So we have log pi is equal to 0.49 and similarly log 2 is 0.3 something. So definitely it is not equal to 1. So option C is incorrect. Let's see the fourth one. Sine alpha is equal to sine pi by 2, which is equal to 1. So option 4 is the right one. Next question. Let V be the vector space of all polynomials P with a degree of P less than or equal to n. Let T from V to V linear transformation be the mapping of T of P of x is equal to P dash of 0. Which one of the following are correct? So dimension of kernel of T equal to n, range T equal to 1. Then kernel T dimension is 1 and range T dimension is n plus 1. Let's see. So the question here is degree of the polynomial is less than or equal to 1. So we can take a polynomial which is equal to whose basis is 1x square because less than or equal to n. If I am taking 2-degree polynomial, so that the basis elements are 1x square, right? So this will be a0 plus a1x plus a2x square. So the basic elements 1x square. Let's see here transformation from t of px is equal to p dash of 0. So t of 1 is equal to here p dash, that is differentiation of 1 is equal to 0. So you have to write this in the linear combination of the basis elements. So here 0 into 1 plus 0 into x plus 0 into x square. Now t of x, the next element, whose differentiation which is equal to 1. So this can be written as 1 into 1, right? This you have to write 1 into 1 plus, here there is no x element, so 0 into x, then there is no x square element, so 0 into x square. That's the third one, t of x square, whose whose differentiation is 2x. This becomes 0 because here it is p dash of 0. In the place of x, you have to put a 0. So this is 0, which can be written as 0 into 1. Here there is no x element, so 0 into x plus 0 into x square. Similarly, if I am taking t of x cube, whose differentiation is 3x square, again it becomes 0. So 0 into 1, 0 into x, 0 into x square, 0 into x cube, like that. So what I am taking, put this in the matrix form. So here 0, 0, 0. So write in the column form. Then the next 1, 0, 0. So the next is 0, 0, 0. Okay. Now you can see that a rank of T. So number of non-zero rows, that is the rank. So here this is 1, which is otherwise said to be the dimension of the range space. That is also the rank. So here which is equal to 1. Now let's see the null space. So here after the rank there is 2 null space. So which is equal to n I am writing. Here there is 2. So for polynomial 2 there are 2 null space. Polynomial 3 there are 3 null space. So for polynomial n, the question is here polynomial less than or equal to n. So there are n null space. So that is set as dimension of the kernel. Right. So you can see here dimension is equal to rank plus nullity. Here rank is 1 and nullity is n. So that is n plus 1. Here itself you can see that dimension of 2. Dimension of 2 is equal to what? 3. So dimension of 3 means, that is polynomial 3 means 1x, x square, x cube. There it is 4. So here it is 2 plus 1, that is 3. If it is 3 means 3 plus 1, 4. So here n degree polynomial means n plus 1. It is compensated. Let's take these options. Dimension of kernel T equal to n. So dimension of kernel means null space. Okay, dimension of null space is n. You can see here dimension of null space is n. So this is the correct option. And let's see the B part, dimension of range T. That means dimension of the rank, that is equal to 1. So this is right. So these two are the wrong options. Okay, here kernel T is n. So here 1 is the wrong and range T is 1. Here it is n plus 1, that is wrong. Okay, thank you.